This is a video about finding a minimum time it takes to travel. The question states, a lifeguard spots a drowning child in the water who is 200 feet along the shore and 100 feet from the coast. If the lifeguard can run 10 feet per second and can swim 4 feet per second, how far should the lifeguard run along the shore before jumping into the water? So to solve this problem, let's first sketch a diagram. And here's my diagram. Here's my lifeguard right over here. And my child is out in the water, 200 feet along the shore and 100 feet from the shore. The lifeguard is going to run along the shore till he gets to somewhere around here and then start swimming until he gets to the child. If I call this distance from where he jumps in to the edge of the shore here x, then if the entire shore distance is 200, the running distance will be 200 minus x. And we can use the Pythagorean theorem because we have a right triangle with legs 100 and x, and say that the swimming distance is the square root of 100 squared, which is 10,000, plus x squared. So now let's find out the total amount of time it's going to take the lifeguard to run along this path and then start swimming to get to the child. And we're going to use the famous formula, distance equals rate times time, or time equals distance over rate. And we proceed as follows. We can say that the total time is the time on land plus the time in the water. The time on land is the distance, 200 minus x for the lifeguard, divided by the rate, which is 10 feet per second that the lifeguard can run. The time in water is the distance the lifeguard is swimming, which is the square root of 10,000 plus x squared, divided by the rate, which is 4 feet per second. So here's my total time. I want to minimize the amount of time the lifeguard takes to get to that child, because that poor child is going to drown if that lifeguard doesn't get there in a hurry. So to minimize, we take a derivative and set that derivative equal to 0. So we take a derivative. 200 minus x over 10 is the same as 20 minus x over 10. The 20 goes away when we take a derivative, and the minus x over 10 becomes a negative 1/10. So to take the derivative of the square root of 10,000 plus x squared over 4, the over 4 stays there. The derivative of x squared, the inside, is 2x, and the derivative of a square root is going to be 1/2 divided by the square root. The 1/2 and the 2 from the 2x cancel, and I'm left with x over 4 times the square root of 10,000 plus x squared, and I set that equal to 0. So at this point I can solve. I could multiply by the common denominator and then isolate the root and square both sides and solve for x, but honestly I used a calculator to do this, and what I ended up getting was that x was about equal to 43.6. I don't really want x, I want 200 minus x, because that's how far the lifeguard is going to run before he jumps in the water. So 200 minus x is 200 minus 43.6, or 156.4. And now we can answer the question. The answer is, the lifeguard should run about 156.4 feet along the shore before jumping in. And I'm done with the problem.